So we're asked to determine the magnitude of the force FAC acting along the z-axis. So we're only interested in this wire, this force here. And what we need to do is put FAC in terms of I and J and K components. So that's the Cartesian vector form. If we're able to do that, all we need to do is pick out the K component because that corresponds to the part acting along the z-axis. Okay. So the first kind of step is going to be to get a unit vector that tells us the direction of this arrow. A unit vector is a magnitude of 1 vector, and yeah, it just tells you the direction in I, J, and K parts. So to work it out, we're going to need to use the distances because we're given like that this has a height of 9, so that's going to be like the arrow here. We can use that it's going to be going down 9 units, and we're also going to need to know kind of how far it goes along the x-axis and how far it points along the y-axis as well. Once we know that, we're going to be able to calculate the unit vector. Now, unfortunately, this time we are not given directly the x and the y parts of this. We're given this line here has a magnitude of 3, and we're given the angle of 30 degrees. So from that, we should be able to work out this line's length, which would correspond to how far it goes on the x-axis, and we should be able to work out this line's length, which corresponds to how far it goes along the y-axis. So let's start by taking out that triangle. Okay. So it's got a magnitude of 3 here. We know it's got an angle of 30 degrees. This side corresponds to the y part, so I'm going to call this ry. And this side is the same as the x component, which is rx. And we know it's going to be a right-angled triangle because the x and the y axes are always 90 degrees to each other. So we need to work out rx and ry in terms of these other two. So if I start with, let me go with cos first. So cos of 30 has to be equal to the adjacent over the hypotenuse. So ry divided by 3. That's going to give me what ry actually is. So 3 times cos 30, it works out to be 2.598. So now if I use sine of 30, it's going to be the opposite, which is rx over the hypotenuse of 3. So rx is going to be 3 times sine 30, and this works out to be 1.5. So we now know how far this vector points in terms of the x and the y directions. So let's move on to writing out our kind of distance vector. So I'm going to call this r, and we'll say it's equal to the x component, which is 1.5. And we need to think about whether it's pointing in the positive or the negative x direction. This time it's pointing outwards from the x direction this way, so it's going to be positive. We know the y component is 2.598. It gets a j for being in the y direction. Again, we need to think about the direction. So this is pointing like positive y direction, so it gets a plus. And finally, the z direction, this one was really easy. They've given it to us directly. We know it's got to point down 9 meters. So it's going to be downwards, so it gets a negative, and it gets a k for being along the z-axis. So we're also going to need to know the magnitude of this vector, okay, which is why we give it the little bars. And we can work this out using the Pythagoras Theorem. So we square all of our components and take the square root of them. And this comes out to be 9.487. So we should be able to now calculate the unit vector, and I'm going to call it UAC and give it this little hat to represent that it's a unit vector, which means it has a magnitude of 1. So it's going to be equal to our vector r divided by its magnitude. Okay, and all this does is basically take your vector and normalize it so that it gets that magnitude of 1. So substituting in, we get this. And now you just need to take 1.5 divided by 9.487. You end up with 0.15 8. This number divided by this number becomes 0.274. And 9 divided by this becomes that with a k. Alright, so now we know the unit vector. What we're going to be able to do is use it to calculate what the force should be along AC in terms of those I, J, and K components. So again, we can use this equation with our unit vector to say that it's going to be equal to our force vector, I'll call it FAC, divided by the magnitude of the force vector. Okay, we know that it's got to point in this same direction represented by our unit vector. So if we rearrange it for FAC, okay, this is what we're going to answer with. We get this. And we know that magnitude of FAC, it's going to be 3 kilonewtons. So it's just a matter of subbing that in along with our unit vector we've already pre-calculated. And working it out. So this is just scaling up this 1 unit long vector to now be 3 units long. So we can multiply it out. Okay, that's what we get. We can put some units on this one. So we know it's going to be in kilonewtons. Simply because this 3 kilonewtons up here was what we used. So the final answer for this is it asked us just for the magnitude of the part acting along the z-axis. So that's referring to our k component. So I'm going to call it FAC and put a z on here. Magnitude means you always take the positive version. So the positive version of this is 2.846 kilonewtons, and that's the final answer. So that's all there is for that video.